In this demo, we will connect one of our containers with one of the networks that we have created. First of all, let's see if we have any running containers. The container should be in running state since network object connectivity in Docker follows the rules of interprocess communication in Linux. Which means if there is no process, nothing can talk to it in terms of networks. As we can see, we have two of our spare containers from previous module, but both of them are in exit state. Let's start my Ubuntu container. Now, keep a list of networks in front of us to make better decisions. We will use docker network connect command followed by network name and container name and hit enter. We don't get any sort of response like network ID or container ID from Docker, so a fair way to verify the connection would be to use docker inspect command. After using inspect on my Ubuntu, if you navigate to the networking fields of the output, you can see that we have description of bridge network mybridge1 attached to my Ubuntu container, and it also has the alias which is same as the one we had received after creation of that bridge network. You can also notice the endpoint which is described with an endpoint ID. In our next command, instead of using a separate command to connect the Docker network, we will mention it along with the run command using network flag. Here we are providing host network to the container named cont_nginx, which will be created from nginx image having the latest tag. Notably, if you run docker container port command with cont_nginx, you won't receive the port mapping information since no port mapping takes place with host network driver. Container communicates to internet using port of host itself. We can view more information about this host network using inspect command on container. And as you can see, we can get network ID and endpoint details of the host network instance. Just like in previous container, here too you can notice a field named bridge under network settings. This field is empty. The reason is if we do not provide any network manually, Docker provides the default bridge network to every container. Now let's inspect the default bridge network. It seems that it too has its endpoint, subnet and IP address range. Now, if we look at the containers field, we will find my Ubuntu, or to be precise, only my Ubuntu. The reason why cont_nginx is not listed here is that it is connected to the host network. Docker connects the container to one of the default networks, and mostly the priority is bridge unless we mention otherwise explicitly. Note the IP address of my Ubuntu under default bridge network, which is 172.17.0.2. Now let's inspect user defined bridge network. In our case, my bridge1 network. It has similar parameters compared to default bridge apart from different endpoint, IP range and IDs. It also has my Ubuntu container connected to it, but the IP is different from the default bridge. In other words, my Ubuntu container can be accessed from both the networks using corresponding IPs. We can also format the output of inspect command like we used to do it previously. Let's grab the value of scope field of default bridge network. Or we can grab a set of ID and name for the same. As it is visible in the output, the first entry is the network ID and the second one followed by a colon is the network name. Now let's list our containers again to see what to do next. Well, we can see what happens when we disconnect a network from a container. Let's use docker network disconnect command followed by network name and container name, which are mybridge1 and my Ubuntu in this case. Finally, if we inspect our network, we can see that container my Ubuntu, which was previously mentioned there, is successfully out of sight. Similarly, if we inspect the container, we won't find the user-defined network either.